Okay, so this is a question based on the homework, one of the homework problems. And the homework problem basically had, oh, let me see if I can, I don't think I can pull that up here, but it had a box where you had to draw, and then there was an arrow, another box, and you had to draw the reactant and the product for the equation for the hydration of a particular molecule. So it's either going to be an aldehyde or a ketone. So I'm going to show you one example of each of these. So let's start with we'll start with the aldehyde. So this is hexanal. So this is an aldehyde that has 6 carbons, and all aldehydes end in Al. So that's where the Al comes from. So when we look at this, sometimes you're like, oh, I don't know how to draw this, but you actually do. If you know the functional groups, you actually know how to do this. So what is an aldehyde? So if you remember, your general structure of an aldehyde is an R group, a carbon, double bonded to an oxygen, and then you got a hydrogen. Remember, there's only one R group. It's all alone. That's an aldehyde. And what we're saying is that we're going to add hydrogen to that aldehyde, and we want to know what's going to happen. What are we going to make? Well, you know this because we did this in class. We said this is an aldehyde, and if we add hydrogen, is that oxidation or is that reduction? Adding hydrogen would be a gain of hydrogen. A gain of hydrogen is a reduction reaction, right? So when we do this, we're going to add hydrogens. Well, where are those hydrogens going to go? Well, the oxygen is going to pick up one, and then the carbon is going to pick up one. So if we redraw our new molecule, we have that carbon in the middle. It had an R group and it had a hydrogen. Now it also, and it had an oxygen, right? But that oxygen picked up a hydrogen, so it no longer has a double bond between the oxygen and the carbon. And then you have another hydrogen that came from the H2, and that adds to the carbon. So now we no longer have an aldehyde. What do we have? We have a primary alcohol. So that's just a model reaction for what you're going to do. So look at A, hexanal. So hexanal is a 6-carbon ketone. Oh, no, I'm doing hexanal, 6-carbon aldehyde. So if we do this, a 6-carbon aldehyde, I'm going to start with that same carbon and double bond and a hydrogen, but what's that R group going to be? Well, if in total I have 6 carbons, this is going to be my first carbon. So I much prefer to draw in a skeletal diagram. It's just so much easier. So I'm not going to draw my hydrogen, right? Because it's skeletal. So I'm just going to basically draw that. And that is carbon number 1. It's got a hydrogen attached to it, but we don't have to show it. That's 2, 3, 4, 5, 6. So now I have a 6-carbon aldehyde. Now all I have to do is add hydrogen to that 6-carbon aldehyde. And when we do it, you do need a catalyst, right? But what's going to happen is that hydrogen, one of the hydrogens is going to go to the oxygen, and one of the hydrogens is going to go to the carbon, but they're going to go to the atoms that flank that double bond. So the carbon involved in the double bond is carbon number 1. The oxygen involved in the carbon is right here. So this is that carbonyl group that we talked about. So one hydrogen goes to the oxygen of the carbonyl, and one hydrogen goes to the carbon of the carbonyl. So let's draw our product. What are we going to get? Well, draw your 6-carbon chain, right? So 6, 5, 4, 3, 2, and then this is 1. So this was the carbon-carbon double bond, but it's no longer a carbon-carbon double bond. Now I still am bonded to an oxygen, but that oxygen now has a hydrogen. And then I added another hydrogen to this carbon right here, but because we're in skeletal, we don't have to draw it, but you have to know that this is a carbon. So my lines are not real pretty here, right? But really make your lines nice and pretty, and you're going to see that nice change from one to another, right? Okay, so then you can see that that's an angle. And when you draw it in the program, by default, it's going to draw it that way. Okay, so we went from an aldehyde to a primary alcohol, right? That was our thing. It's a primary alcohol because we only have one R group. So if here's our alcoholic carbon, or our carbonyl carbon, we have one R group. So that tells us we have a primary alcohol. And that's why you went from an aldehyde to an alcohol. Okay, I'm going to erase all this and we're going to do D. So let me take all this away. Okay, now we're going to do D. So D is 6-ethyl 2-octanone. ONE tells me it's a ketone. So it's telling you here, you don't have to know the name yet, but it's telling you here that this is a ketone with an 8-carbon parent chain. Let's remember, what's a ketone? Ketone has 2 R groups, but that flank the carbonyl. Instead of being 1 R group and a hydrogen, it's 2. So here's my ketone. And a ketone, oh, I did R1, R1, R2. And I'm going to hydrogenate it, right, for the hydrogenation. So I'm going to add hydrogen. So now what's going to happen is the oxygen's going to pick up on the flanking the double bond. The oxygen's going to pick up one of the hydrogens. The carbon's going to pick up one of the hydrogens. So what do I make? In this case, you keep your carbon, keep your oxygen, but your oxygen picked up a hydrogen. You had these 2 R groups that we're going to keep. And then the carbon picked up that other hydrogen, right? So these are the 2 green hydrogens that were here. So we went from a ketone to now a secondary alcohol, right? And when we went from that ketone to the secondary alcohol, we are adding hydrogens. This is a gain of hydrogen. We said a gain of hydrogen is a reduction reaction. It didn't ask you for that, but it's just kind of good to keep in mind. Okay, so now we just have to make this 6-ethyl 2-octanone. Well, what does that tell you? The oct, let's do a different color. The oct is telling you that's 8. The one is telling you it's a ketone, so I'm going to have 2 R groups. So how long are the R groups? Well, it just depends on the placement of the ketone. So the 2 here is telling me that the carbon double bonded to the oxygen is at carbon 2. So let's just draw 8 long, and I'm probably going to make this molecule way too big, but that's okay. So we got 1, 2, 3, 4, 5, 6, 7, 8. So now I have a chain that's 8 carbons long. That's a 1. Then it tells me at carbon 2, so I'm just going to erase my number for 2. At carbon 2, I have a carbonyl. So I'm going to draw a double bond to an oxygen, okay? But that's not all that we have. We also have a 6-ethyl. So just go to carbon 6 and I put an ethyl group. So coming off of here, methyl, then that's an ethyl. So that tells me that that's my structure. Now all I have to do is add hydrogen in the presence of a catalyst, which we don't have to worry about for this. What's going to happen? Well, we know one of the hydrogens goes to the oxygen of the carbon-carbon double bond. One of the hydrogens goes to the carbon of the double bond. So I'm just going to take this. I'm going to cheat. And I'm going to copy it. Missed the one. Okay. Copy, paste. Okay. So now what's going to change? Well, I'm going to lose the double bond. And my hydrogen's going to go there with the oxygen. But what else changes? And you kind of place it on the tip like that now. So what else changed? Well, this other hydrogen bound to this carbon. But do I draw hydrogens on a skeletal diagram? No. So I don't have to worry about it. So that's all that changes. The hardest part is drawing the initial substance. But if you look, they should give you that information. Okay, hope that helps.